When calculating utilities of two strategies, so if we have a matrix A and a matrix B for our two players, and if we have two strategies, sigma R and sigma C, then we can actually use a linear algebraic notation to write quite a compact way the utility calculations. So in this particular case, we have sigma R, UR sigma R sigma C is actually written as sigma R, the vector R, sigma R multiplied by the matrix A, multiplied by the transpose of the vector T, sigma C, pardon me, the vector sigma C. And then if we have U, C, so for the column player in the exact same situation, we have a very similar notation, except it's the matrix B. And this allows us to have this quite compact notation, take advantage of some linear algebraic tricks later on, and also sometimes the calculations can be a bit faster to even carry out. And so if we consider the game rock, paper, scissors, put that over there. It's a bit smaller than I intended it. Let me put it over there. If we have the game rock, paper, scissors, where we had A equals 0, 0, 0, minus 1, 1, 1, minus 1, minus 1, 1, and B is equal to minus A. And if we consider the case of sigma R equals a third, 0, 2/3, and sigma C equals a third, a third, a third, then we can in fact do these calculations using the linear algebraic approach above, where we can say, okay, and I will make this slightly smaller so it all fits on the screen. We can say, okay, U R sigma C is equal to sigma R, which is a third, 0, 2/3, times the matrix A times the transpose, so the column vector a third, a third, a third. And if we write that out and using this matrix A here, we see that's equal to minus 2/3 times a third times a third, multiplied by a third, a third, a third. And if we look at that, you will see that in fact we have a 0 there. And if we did the exact same thing for the row player, except by replacing this with a B, when we're doing it for the column player, pardon me, we would also get a 0. So that's a way we can use linear algebra to do these calculations.